Okay, guys, this is the conjugate acids and bases video, and it won't be too long. It's a pretty short one. But anyways, first of all, a conjugate acid is the ion or molecule formed when a Bronsted base accepts an H plus ion. Okay, so you remember Bronsted base is one that receives H plus ions. A Bronsted acid is one that is going to give up H plus ions. Okay, so if those definitions don't make sense to you, understandable, let me show you. First of all, we have an acid, which is HCl. Okay, 99% of the time, 95% of the time, the hydrogen is going to be listed first. That's what tells you it's an acid. Okay, and then we have a base. And according to the Bronsted-Lowry equation, what's going to happen here is the acid, whichever one's the stronger acid, is going to do this. Okay, HCl is a stronger acid. It's going to give its hydrogen ion to water. Water's going to receive it. Okay, and then we're going to go ahead and form Cl negative and H3O plus. Okay, now here's what happens. Chlorine negative, the system really is in equilibrium. Cl negative can now go ahead and receive that hydrogen plus ion back and go in the opposite direction. Okay, so what happens is HCl started out as an acid. Once it did its acid thing, gave it its proton, it then becomes a base, which we call a conjugate base. Okay, the base, which water is acting like a base in this instance, remember it's amphoteric. Okay, it did its base thing and received its hydrogen ion. Well, now it has a hydrogen ion to give up, so it's now an acid, which we call a conjugate acid. So think of conjugate kind of being like the opposite. Okay, so let's try a few of these here. If I give you this compound, HSO3 negative, okay, and I ask you what is the conjugate base of that compound. Okay, so if I'm asking you what's the conjugate base, then I'm telling you inadvertently that this must be the acid. So what do acids do? They give an H plus away. So if it gives its H plus away, it now becomes SO3. Start as a 1 negative. When you lose a positive, then you become 2 negative. Okay. So let's try the next one, H2O. What is the conjugate base of H2O? Now again, if I'm asking you the conjugate base, I'm telling you H2O then inadvertently must be the acid. So whenever we do these, we only give up one H plus or one proton. Okay. In real life, they can give multiple ones away, but anytime you're asked to do conjugate acids and bases, we're just going to do one. Typically, they usually only give one because that's the easiest one to give away. The other ones are bonded a lot stronger. And so if we give away a hydrogen, we only have HO or OH, and you can put HO if you want, that's fine. Start out as neutral and you lose a positive, you are now a -1. Next one, NH4. If it does its thing and gives away a proton, becomes NH3. If we start out as a positive and give away a positive, then we become neutral. So let's try another thing for conjugate acids. Okay, so let's try this. If I asked you, what is a conjugate acid of OH negative? Again, we're only doing one proton. So if I'm saying what is a conjugate acid, then what I'm telling you is this must be, OH negative must be a base. What do bases do? According to Bronsted-Lowry, they receive an H plus ion. So once it receives an H plus, H2O. Next one, what is a conjugate acid of H2O? Well, if I'm asking you the conjugate acid, then I must be telling you that this is a base. Therefore, if it's a base, it's going to receive an H plus ion. If you start as neutral, gain a positive. There's our H3O plus hydronium ion. HSO3, again, what's its conjugate acid? Well, it's going to receive an H plus ion, so it's H2SO3 3. If you start as a -1 and you gain a positive, you then become neutral. Okay, we'll be focusing on this a little bit more, but the last thing is neutralization reaction. Anytime you mix an acid and a base, they produce a neutral solution. Okay, now they're always going to produce two things. Mix an acid and a base, they always produce a salt. In this particular case, it's sodium chloride, and that's actually water, H2O, if you rewrote it. Okay, when you mix baking soda and vinegar, they produce a salt and water. That particular salt is sodium acetate. Okay, so it just depends upon what two acids and bases that you mix. And if you notice, NaCl is neutral as well as H2O. So you take two very dangerous substances, such as HCl, okay, which is what you put in your pools, muriatic acid, or sodium hydroxide.
Okay. Good luck on your test. Easter break's only 1 month away.
Okay, so basically the stronger the acid, the weaker its conjugate base. The stronger the base, the weaker its conjugate acid. So using that chart that we just looked at, if we have two compounds, HBr, and which is hydrobromic acid, and this is carbonic acid, and we need to decide, okay, well, they're both acids. Which one is going to act like the acid and which one's going to act like the base? Well, the answer is whichever one on that chart is the stronger acid, which in this case is HBr, is going to act as the acid. Whichever one's the weaker acid is going to act as the base. So what we're going to have here is HBr is going to give its proton to carbonic acid. Okay, next one, NH3 and H2O. Well, which one's the stronger acid? Which one's the stronger base? Well, in this case, H2O is the stronger acid, and NH3 is the weaker acid. So it's going to act as the base. So in this case, because H2O is stronger, it has more of an affinity to give up its proton. In this case, H2O is going to act as the acid, and NH3 is going to act as the base. All right, that will conclude conjugate acids and bases. Okay, relative strength. If you notice some of the stronger acids over on this side, and then they get weaker as you go down here. And what we've got here on the other side is strong bases down here and weak bases up here. So if you notice, these are the conjugate bases of these acids. Okay. All right. So if we notice, what I want you to notice from here is that if you have a very strong acid, its conjugate base is very weak. So you can't do both things really well. You either give up hydrogens very easily, in which case you're a strong acid, or you receive hydrogens and hold on to those hydrogens, in which case you're a strong base. So you're going to be one or the other. Some of them in the middle here, such as water, are amphoteric. They're kind of do both things mediocre.